Welcome to you all watching from home, the office, or any other creative place. This is the OpenValue meetup. Tonight we have two talks for you. The first will start in a few minutes, then we'll have a short break, and afterward we will continue with the last session. The sessions are being recorded and will be published later on this YouTube channel. Might be maybe tonight, maybe in a couple of days. You'll see them appear. Each session will take about 30 to 35 minutes, and then we will have some time for questions. If you have any questions during or after the talk, please ask them in the chat, and I will forward them to the speakers in the Q&A after each talk. So that's it. Now, without further ado, let me introduce the first speaker to you. His name is Robin. He's very passionate about software and very eager to try new technologies, one of which he will now tell you more. Please give him a warm applause via the chat, and the stream is all yours, Robin.
Right, thank you very much, Paco. Welcome all, thanks for joining this talk. I'm going to tell you about how I build a platform native CLI with the technologies mentioned over here, which are Kotlin, Clicked, and GraalVM. So let me first introduce myself. So my name is Robin Trietsch. I'm a software engineer at OpenValue. Currently, I'm building a stream machine. I'm helping to build an event processing platform that focuses on privacy and data integrity. I mostly work with the JVM, with the JVM languages such as Java and Kotlin, and with the data engineering stack. So think of Kafka, for example. And well, I'm always looking for new tech to try out, and that's also how I decided to try out GraalVM, which is a key component here in this talk. So well, let me first tell you something about the Stream Machine. I already told you what the focus is of Stream Machine. And well, Stream Machine has a public API, and well, this public API, of course, has an open API specification, and well, this allows us to generate a nice Swagger page for customers to interact with. However, it's not really straightforward to use the API, because you need to do some steps. Most of the endpoints are protected with some authentication. So first you need to authenticate with Stream Machine, and well, the next steps is actually to use these APIs. However, we felt the need to give customers a better tool to actually use these APIs and interact with Stream Machine. So, well, that's how we came up with the idea to create a CLI. Stream Machine also has a front end, a portal. However, this portal, yeah, as all front ends do, they require a lot of attention to show all the features that a product is capable of doing, and therefore, as we're only backend developers yet, we decided to go with a CLI, because that allows us for well, quickly actually exposing features to customers. So that brings me to the need for building a command line interface. As I already said, it's quick and easy to develop. As a backend engineer, you only when you have a new endpoint, you add a new command to the CLI, and it's directly ready to use. The CLI can be very feature rich. It can do a lot of complex commands, and also do all the handling of authentication. And also pretty important is the option to do auto completion. As APIs can grow very large, it's really nice to have something as autocomplete, because then you don't have to remember what the API looks like, all the options that the API offers, because the CLI can explain it to you. So let me state the goal and the problems that we had here. So the goal was to build a multi-platform rich command line interface with autocomplete options. And we faced actually the following problems. So the first one was the language of choice. The second one was the framework or library that we were going to use for parsing arguments. The third one, creating a platform native binary, because you want to run it as standalone. You don't want to be dependent on other dependencies that should be installed on the platform that you're running it on. And the fourth issue is actually cross or multi-platform builds. So ensuring that these native binaries run on every large platform. So let me go to the first issue. So the language. As I write a lot of Java and Kotlin, those languages, well, they first popped up, of course. However, when writing a command line interface, you often think about Python, for example, but also Golang. A command line interface that that is written in Python is, for example, the Google Cloud command line interface. And Golang is also very popular because of the libraries that Golang offers for parsing command line arguments. However, we decided not to go for Python because you need to have Python installed. And of course, it's installed on most platforms. And we decided not to go for Golang because we didn't have a lot of experience writing Golang yet. So that left us with the JVM languages. Well, then it's an easy choice for me. I like writing Kotlin because it's much more concise than Java. So that's how we came up with writing it in Kotlin. That brings us to the CLI library or framework, if you would like to call it like that. There are two major ones that can be used with Kotlin, which are Pico CLI. Pico CLI is annotation based, and well, it's very extensive. You can do a lot with Pico CLI. However, because Clicked is native for Kotlin and has a very nice DSL for Kotlin, we decided to go for Clicked. Pico CLI also has this list of command line interface library comparisons, and the link is listed below. There are listed dozens of libraries and frameworks. So that brings us to the third one, native binaries. Well, for the JVM, I only know of one, and that's GraalVM. So that's an easy choice. Well, then the fourth issue, cross-platform builds. There we have multiple options. The first one is doing it by hand. GraalVM doesn't offer a cross-platform compilation out of the box. Actually, when you want to compile a binary for a macOS machine, then you have to build it on a macOS machine. Same applies for Windows, same applies for Linux and Unix. So if you do it by hand, then you need all of these machines. Well, the first thing that pops up then is doing it in virtual machines. However, you also need to manage these virtual machines then. And what's better than managing virtual machines yourself? Let somebody else do it. So that's where GitHub Actions comes into play. GitHub Actions offers different machine types to actually execute parts of a CI pipeline, and that's how it allows to choose a certain platform. So GitHub Actions was the choice there. Well, if you want to go this way, then you have a few prerequisites. The first one is having GraalVM installed, of course. The version that I've got installed is 23.0 R11. R11 stands for Java 11 here. If you would like to use Java 8 for some reason, then you can go with R8. The second one is installing the native image GraalVM component for actually doing the compilation of your application to a native binary. So I talked about Stream Machine, and I would like to see if you can guess this. Which other everyday product needs a CLI? So Paco, can you help out here? See if people say something.
Yes, if you have any answer, please put them on the chat. There's still.
Let's give it 15 seconds.
Okay. It's still.
No comments. All right. Well, it's probably the delay. Let's keep it at the delay. All right. I'll just give it away. It's Spotify, of course.
Sorry. The cooker was an answer.
Oh, cooker. That's also a good one. Well, I decided to build a CLI for Spotify with these technologies because Spotify is an everyday product that a lot of people are using and are familiar with. And how cool would it be if we would have the option to just type in our terminal that our Spotify should start playing? That's way easier than using the actual application for your desktop, of course. So let's continue to the demo. So I'll be showing how to set up a Spotify application. That involves going to the Spotify developer dashboard. Next, I'll show how the CLI authenticates to Spotify. I'll be showing how to store the access token. And the last one, the best part, of course, is controlling the playback of Spotify. So let me go out of here. Let's first go to the developer dashboard. So if you log into the developer dashboard, let's see if I'm still logged in. Yeah. Then you'll be shown, if you don't have any apps, this will be empty. I already created one for the CLI. But if you want to create an app over here, so say my awesome CLI, click the two checkboxes and create. So we have this, you will get a client ID and you can show the client secret and copy it. Take note of these because we will be needing these later. One more important thing, because we'll be doing an OAuth authorization code flow, go to the settings and add a redirect URI. So this will be my redirect URI over here. And of course, you can add more if you want. But as the CLI is always running on your machine, it will always be localhost as the redirect URI. So I will be talking to the Spotify API using this Spotify web API for Java, which of course can also be used in Kotlin. And this is a very easy way to interact with the Spotify web API. Let me go to the code. So as you can see, this is a simple Maven project. And this Maven project has the following dependencies. We'll be using clicked. So that's CLI KT. We have some dependency to print color text to our CLI. GraalVM dependency in standard lib. I'm using Hocon configuration files over here for some config of our CLI, the Spotify web API, and the servlet, JavaX servlet API, and Jetty servlet for the OAuth callback. So let me actually go to the code. So the main entry point here is actually just the main method, and the arguments are parsed to the Spot class, an instance of Spot class. I'll be going there in a second. And clicked does the parsing of the arguments actually for us over here. If we look at the spot class, you extend click command, and the next thing that's important is that you override the run method. The run method can either do nothing or it can do something. It can do nothing in case this is a parent command that has only subcommands and you don't want to invoke anything when it's called. And if it does something, well, then that's the command that is executed. This root command, which is called spot, consists of 3 other commands. And I'll be taking a look at the account command first. So as you can see, the account command is also a click command. That's the structure that you follow all the time. And as you can see over here, this run command actually does nothing. If I go to the whoami command, then you see that this is actually doing something. So it uses the Spotify API, calls for the current user's profile, executes. So there it actually calls the Spotify API. And then if we get a user return, well, then we print this text to the console. However, you see over here that it's wrapped into a run if authenticated. That's a convenience method that I made for just passing along a lambda that will be executed, but only if in certain cases. So as you can see, we need credentials because, of course, we need to authenticate ourselves to Spotify, and we actually need to have valid credentials to do the call. So say, for instance, that we don't have any credentials. Well, this will return a null, and then we'll end up over here, and it will state that I'm currently not logged in. I also print the instructions on how to actually get a valid token. If we do have credentials, well, then it executes the block, and if it fails, then it will check if the credentials are expired or if it's an unexpected error. So let me go to the get credentials method. So the get credentials method, it actually has a credentials field that is wrapped into a object. This object is a context for the CLI to operate in. I noticed that this is the easiest way when writing a CLI this way, to have a shared context that can be called from anywhere within the CLI, because you need these credentials everywhere. And the same applies, for example, for the Spotify API. The Spotify API you also need everywhere. So let me go back to the get credentials method. Here we try to read the credentials, and we try to read the credentials from disk. Well, why from disk? Because every action you do in the CLI is a separate run of your application. You should see it as standalone. Well, within the run of your application, you have state, but in between you don't. So every run starts with a clean slate. And that's why if we have credentials, we actually need to persist it on disk and actually read it every time we want to execute a command. That's why we take these credentials from disk, and these credentials are stored in the authentication flow that I'll be showing later on. So this credentials file, I just take the user's home and put it in a directory over there, and I write it to credentials.json. So let me actually go back to the root command, so to spot, and let me show you what authentication looks like. So authentication has 2 subcommands, login and revoke. Revoke is pretty easy. It just removes the credentials file. So it's like a clean slate that you have to re-log in. If I go to the login flow, then upon login, I first start a callback server. This is just a Jetty server. And next, I actually build the authorization code URI. with the respective scopes. Don't look at the scopes because they're very wide. That was just the easiest way over here. I'm not using all the scopes, but if you want to fork this project and continue building it, look at the scopes. For convenience, I also print the URI to inform the user to go there, and we try to open the URL in the browser. But if it doesn't work, then you always have the URI printed next to you. Well, then we wait for the server to have a response. Why do we do this way? If I go to start the callback, then you see how it started over there. And if we look at the servlet, it waits for receiving the code. And when we receive the code, we assign it in our CLI context. And next, we stop the callback from there because we don't need it anymore. So that's why we can do a join over here. Well, then we can call the Spotify API with our code and then actually get client credentials. And the last part, we store the client credentials on disk, as I said before. I will actually show you what that looks like. So I already have this binary compiled and on my path. So that's why I can actually do it this way. So as you can see, I also have autocomplete. I'll show you later on how that's done. So let me go to auth, login. So this is the Spotify consent. It shows the name that I gave over here to the CLI. So that's the same name over there, and all the all the scopes that I requested. So let me say okay. Well, it prints that I'm successfully logged in. Return to the terminal to actually start using the Spotify CLI. So what does it look like? It should have stored a credentials file over here. So let me only print the first 50 characters because it's an access token. And as you can see, it actually did write a file over there. So now we should be able to start using this access token to actually do commands. So I already showed you the account who am I command. Let me see. Yeah, well, it knows who I am. Well, that's great. And it's actually correct as well. So you already saw the other command, playback. Let me first show you what it looks like. Let me go to the root command, then to playback. So playback consists of the following subcommands. We have a play and pause. It can show what's currently playing, and also the devices that I'm able to play music on. So the Spotify API requires when you start playing music that you specify the device that you want to play music on. So let me first go to the devices command. And this devices command consists out of two parts, listing devices and setting a default device. Listing devices, well, pretty straightforward. Just ask for the user available devices and print them to the console. With set devices, it's a bit more complex because we want to have a completion option for this command. And here you see that I'm actually using something from Clicked, which is parsing arguments. So I'm requesting an argument with the name. I'm specifying the help text that should be displayed, and also showing completion candidates. So these completion candidates are actually invoked from a standard out by invoking another command, and that's actually spot playback devices list. So that's actually this command that I'm invoking over there to do the autocomplete. Let me also show you what the help looks like. So this is what is printed to console if you specify help. And as you saw before, you also have autocomplete options, and that also works with options and with flags. So we have autocomplete for this name, for the device name, and what we actually do here is verifying whether the name specified by the user is actually existent. If it exists, then we print it, or we actually print that we set the device, but we also actually store it in a preferences file. So if I list this directory, I only have credentials right now, and I actually have to set the default device. So let me first list them. There you go. Well, that's this machine. Set the device, and as you saw, I pressed tab and it auto-completed to this machine. Set it. And if I list it now I have a preferences file. And actually, I'm not storing the name of the device here, but the device ID. And that's also why I'm not printing it completely, because it's device ID. But I've got the default playback device ID saved here. So now I actually should be able to start playing music. So let's start. Right? What is it playing? The show command shows what I'm actually playing. Feeling Me by, okay. Oh, it's correct. So it's the song in need. Let's actually pause it. Well, there we go. We controlled our Spotify through the CLI. All right. I already said at the beginning that you should take note of the client ID and client secret. Actually, I briefly showed it to you. So let me go to the context. But the magic is done over here. We provide the client ID and client secret. These are actually taken from a config, and this config is provided by typesafe config, which is a great library for reading HOCON configuration files. And I'm parsing it here into a data class for convenience. So I specify the client ID and client secret here, as well as the callback, and the port and path are also coming from the configuration file. Well, that's actually that part. Now to the part where we build a native image. The native image, I have GraalVM and the native image component installed. And with the native image plugin, you can actually invoke it from Maven. So you can bind it to a specific execution goal. And well, that helps for just executing your standard Maven commands to actually build the native image. Well, you see a lot of flags or options over here. I don't know what all the flags mean. Some flags are required, and you just do some trial and error to figure out which ones ensure that your build works. So it might be possible that not all of them are required over here. But the ones that are required, well, HTTP and HTTPS, of course. HTTP because we're talking to localhost, and HTTPS because we're talking to the Spotify API. These ones are also very important. Initialized at build time. So these packages are ensured that they are initialized at build time. This was the first time that I actually needed this. That's because this is an OAuth authorization code flow. Therefore, I needed Jetty and a servlet to run. And these require to be initialized at build time. One last thing, I want to include the resources. So the resource that I have over here are actually these configuration files. These are required for reading them into our CLI configuration class. Then a last thing that's very important, which is the reflection configuration. The reflection configuration is very important for GraalVM because you need to instruct GraalVM what classes look like, which objects or which fields do they have, and how GraalVM should interact with these classes and objects. If I show this file, you see that it's a pretty large file, this is what can really bite you when you start using GraalVM. You really have to instruct it how to work with objects. This really comes into play when using libraries such as Jackson and JSON, which really use reflection. So if your build fails, or if it fails at runtime, actually when using the binary that you compiled, first think of reflection, because that's one of the first starting points. That brings me to the last part, the cross-platform builds. So I can do a platform build on my machine, which is macOS, but I still want to build binaries for other platforms. So that's where the GitHub Actions workflows come into play. So here we have our CLI release pipeline. It consists actually of two steps. The first step is building the jar. And the second step, which is done in parallel for 3 different machine types, is actually compiling the native image binary. So we ensure that we build the jar, upload it to GitHub artifacts, and these artifacts will be actually downloaded again in the next step to actually do the compilation. So here you see building non-Windows images. So with Ubuntu latest and macOS latest. Here you see the native image command being invoked with all the arguments. It's a bit different from the arguments that I specified in the POM. And also the Windows build. Here it installs a lot of things before you can actually start compiling the native image. But in the end, the goal is the same. It compiles the native image and uploads it to a release. Let me show you what it looks like when going to the actions. So if we go to releases, I configured it so that on every tag, it will start executing the GitHub action. So here you see the release with the Linux, Mac, and the jar. You see that the Windows image is missing. Somehow, I don't know exactly why, but somewhere since last week, the Windows build is failing due to a dependency not being able to be installed. So if I go to the actions, you actually see that it fails, but it failed partially because the Windows build is failing over here. But here you see the 2 steps actually. So building the jar, compiling the images for the different platforms. Well, that's actually it. So let's go back to the presentation. So some caveats. As I already said, reflection is not out of the box for GraalVM. It's really something to think about. By the way, there are tools available, like I think it's a Maven plugin that you can use to actually generate these reflection files so that you don't have to write them yourself manually. Well, as I just shown, the Windows build broke. Yeah, I don't know exactly why. I don't have a Windows machine here, so I can't really figure it out. But yeah, think of that. You have an external dependency on a platform, and builds can break unexpectedly. And also something already said, but sharing state between several CLI commands, you really have to think of the fact that your CLI, that every command is a separate run of your application. So that's something to think about. That wraps it up. You can try it yourself. Go to this URL, and you can follow the README to start, fork the project, create your own CLI, use it any way you want. And another example, of course, this is all based on the CLI that we made for Stream Machine. So feel free to also check out that page, github.com/streammachine.io/CLI. Or if you want to learn more about Stream Machine, go to strm.in. That wraps it up for me. Thanks for watching. And I think this is the time for questions.
Yes, Rowan, thank you for your presentation. I really loved the CLI case you took. It's a fun way to learn new technologies. For the people watching, please put your questions if you have any in the chat. We already had one. The first one was whether the code will be available on but I see the link is already on the slides, so that's nice. It's also in the YouTube channel chat. And the second question is, are you, sorry, there it is. Yeah, whether the file is stored in your machine in plain, and we're talking about the Spotify access token.
Yeah. For now, that's indeed stored as plain text. Yeah, I'm just using JSON here to store it on disk. Yeah, while writing the file, of course, we should set some permissions on the file so that not everyone has the option to read it. Any more questions, Paco?
I currently don't see any coming by in the chat, but I do have one myself. Actually, was it a lot of work to create this Spotify CLI? And is there good documentation on the API?
Yeah, the documentation is actually pretty good. I already knew of the web API. They have very good API docs. However, with this API client, it's really trivial because you can just look at the method names and you know how you can use it. So I think the most work of building this CLI was actually building the OAuth flow, because starting a Jelly server and a servlet inside a native binary, well, that involved some work, and that's why I said look at the reflection config, because I really had to look at the reflection config over there.
Okay, well, I don't see any more questions, but if people still have any questions or come up with them later, they can also reach you on Twitter. I see it's also in the slide as well, at Robin Trietsch. And that's it, I think. Thank you again for this awesome talk. We'll be back in 7 minutes, so at 19:45 local time here. We'll continue. Thanks.
All right. Bye-bye.
Hello and welcome back to the second talk of this session. I hope you had a nice break, and I'm proud to announce our next speaker. His name is Paul Bakker, and all the way from the West Coast. Paul's a Java champion. He is the author of several books and also a frequent speaker at the conference, currently mostly virtual. Again, if you have any questions, please ask them in the chat, and the floor is all yours. Let's go.
All right, thanks for joining, everyone. So I'm going to talk about the DGS framework. The DGS framework is a GraphQL framework built on top of Spring Boot, which we recently open sourced at Netflix. We just open sourced it in January of this year. And we have been using and building this framework over the past 2 years at Netflix, and use it internally in all sorts of different places. So I'll start with a little bit about GraphQL in general. I'm assuming not everyone is super familiar with GraphQL yet. So I'll go into a little bit of the details of how you build a schema and compare it with REST, because that is an easy comparison to make. Talk a little bit about how this framework kind of came to existence and how we use it at Netflix. And then primarily, we're just going to look at the framework, how you actually build something with it. So we're mostly just writing lots of code. If you do have any questions, feel free to ask. We'll see if I can actually answer them. We do have to kind of keep going a little bit as well for time constraints. So I am live from Los Gatos, California. I'm like 3 minutes away from the Netflix campus, which is also in Los Gatos. That's kind of the main campus of Netflix. I moved to California 4 years ago from the Netherlands. I am a Java champion and wrote a couple of books. And at Netflix, I'm in a productivity engineering team, which means we are responsible for the developer experience for our internal developers. And I'm obviously focused on kind of the Java space. Java is the primary language that we use for all our backends and microservices. And in the past 2 years, we have been introducing more and more GraphQL in our backends, and sort of doing federated GraphQL as well. We'll talk a little bit about that later. My team was kind of one of the primary teams behind developing a GraphQL stack on top of Spring Boot, and that is kind of how this all got started. Right, so let's first take a little bit of a look at just what GraphQL is and how it's different from REST and why that is in most cases a good thing. So the most important thing to understand about GraphQL is that with GraphQL you always have a schema, and that's also the obvious difference with REST, because with REST you don't have a schema. And every GraphQL schema has 3 main components. And that's a query type, a mutation type, and subscription type. So in your query type, you basically define the ways a user of the API can get or fetch data from your service. So basically, that's where you define what data you can get from your service. A mutation is where you send data to the server, and the server can process the data. So that's, for example, to store new data or update data and things like that. And so that's almost comparable with like a query would be your get operations on a REST service, and a mutation would be your post and put operations. While a subscription is kind of a different beast that is more focused on streaming. So it is very similar in nature as a query. So you ask the server for data, but you will get continuous updates. And this works really nicely together if you do WebSockets or server-side events. You basically ask the query, I'm interested in this data, and just keep me updated. It is not something that everyone is using in GraphQL, but it can be very beneficial. But for today, we'll mostly just focus on queries and mutations. So let's look at an actual schema. So we're just looking at a query here. So our query type, and this is also interesting, the query type, as I said, is one of the kind of the basic components of your schema, is just a type definition by itself as well. So our type query type is defined with a shows field, which means we basically have a query to retrieve shows from the service. And in this case, it returns a list of show. And show is just another custom type, which we also have to define. So we define a show type with, in this case, a title as a string. A string is just a core GraphQL type. It's kind of a primitive. And we also get a list of reviews, and a review is another custom type that we define in this schema. So based on this schema, you can do some different queries. If you just want to get the title of shows, the right-hand side of the slide shows how the GraphQL query would look like. So the really interesting thing about this is that, as you can see in this query, we have to be specific about which fields we actually want to get back from a query. So we're not just asking for shows. That would actually be an invalid query. We're asking specifically for titles of shows. That means if we run this query, we're just getting titles back. And this projection is projection means that we are specific about the fields that we want to get back. That is a very powerful feature because now we are not doing overfetching. We're not getting more data than we actually want. We are just getting exactly the data that we're asking for. But this can be sort of surprising for folks who come from a REST world, where typically you just get all the data the server decides to send you, and you can't be more specific about that. So if you also want to get reviews data in this example, we can just extend this query and say that we also want reviews. But again, we have to be specific about which fields of a review we actually want to see. We can't just ask for reviews. That would again be an invalid query. From a query writing perspective, this might seem like more work because now instead of just saying, give me everything about shows, now I have to actually write this query. I have to specify all my fields. If a query is quite big and you have like 20 fields, it can feel like a lot of work. But this is really where the power of GraphQL comes from, because being specific about the data you get back, you know exactly what you're getting, and you're also not getting more than you need. So the problem that we are solving here, and again, we can run this query and see that we are now getting reviews as well. And we also see that the response is basically just JSON. GraphQL by specification could run over different transport mechanisms, but in practice, everyone is just using it over HTTP. And the responses you get back is typically always JSON. That's pretty much how everyone is using it. So the problem that we are already solving by doing projections of our data, so we're saying explicitly which fields we want to get back, is we are solving for underfetching and overfetching. One of the problems with a REST API is that a REST API is never perfect for every device that connects to it. So let's say you have an iOS device and you have a browser. Both user interfaces will probably be requiring slightly different data at different points in time. So if you would just build one REST API that satisfies both devices will never get exactly what they need. They will always get more data or not all the data that they're actually requiring. And then to solve that, you have to get into patterns like the BFF pattern, the backend for frontend pattern, which is obviously complicating your architecture quite a bit. You kind of don't need that whole mechanism with a GraphQL API. So we already seen a few differences, but let's put them next to each other a little bit more, comparing GraphQL and REST. So the obvious difference is that with GraphQL, we have a schema, and with REST, you don't. And that is really important because there's a schema, we now have a mechanism to basically communicate our API between front-end and back-end teams without any additional tooling. With REST, you can use something like Swagger to basically generate something that kind of looks like API documentation or a schema, but it requires either a lot of extra work to really annotate your code in a way that Swagger shows you something really usable. And otherwise, it's just not that great to use, honestly. A GraphQL schema very clearly defines what data is available and what data can be passed into a service. So that's a great thing. And based on the fact that we have a schema, we can also do this field projection that we talked about quite a bit already, solving this whole underfetching and overfetching problem. A big difference between GraphQL and REST is that with REST, you typically have a HTTP endpoint or verb, basically, for each set of data that you have. So you would have /shows for show data and /reviews for review data, and these are different HTTP endpoints. With GraphQL, you typically only have the one post endpoint. So you have /GraphQL, that's kind of what most folks are using. It receives post, a HTTP post, and that's it. That can be problematic if you look at caching, because your your basic HTTP cache wouldn't work as well as it would for a GET request in REST. That is true. There are ways to kind of work around that. But in practice, it's way more complicated than that. Caching doesn't typically work very well with REST either, because it's just not that simple. There's whole talks about that topic as well, but it's something to be aware of. Because GraphQL is typically just used over HTTP using JSON, you can use any HTTP client in any language as a client to GraphQL. Same thing as with REST. So you can basically just use it as any other HTTP endpoint and it will work fine. But because we have a schema, we can also create like more advanced clients, such as Apollo client, which has things like caching and that sort of things built in, and it integrates really closely with things like React if you're building React applications. So there's a lot of benefits of having that schema, and there's a lot of technology built around that, basically. Right, so that's kind of the bare bones basics of GraphQL itself. So let's take a look at how Netflix started using GraphQL. So about 2 years ago, we were building many apps in what we call the studio space. So something you might or might not be aware of, but Netflix is one of the largest movie and show production studios as well. So we're basically producing more shows than anyone else. And there's many people involved in every show or movie that we're creating. So there's lots of kind of tracking and administration required to do such things at that scale. And that was mostly done in all custom built applications in that kind of that studio space. What happened there is that we had literally hundreds of different applications, web applications and mobile applications that folks were using in that space, and they were all connecting to our various microservices that we had in that space. Some of these microservices already started using GraphQL to have a nice API for their clients. Others were just using REST. But at some point, what we started getting into is GraphQL Federation. GraphQL Federation is a specification in the GraphQL space. That is completely optional. You can use this framework also without Federation. But with Federation, you can basically create one large GraphQL API, which is composed from different microservices. And it's a specification that Apollo came up with, and we're collaborating quite closely on this specification with Apollo. So anyway, what happened is we started adopting this new federated GraphQL architecture. And what that meant is that all our microservice teams behind that federated architecture would have to adopt GraphQL. And these microservice teams weren't necessarily familiar with GraphQL yet. And they were all Java developers, because our microservices are pretty much standardized on Java, and more specifically standardized on Spring Boot. And that means they were all very familiar with Spring Boot and obviously Java. And now we needed to add GraphQL to that stack. So we started out with just kind of experimenting with the then available GraphQL for Java frameworks. The most important library there is the GraphQL Java library, which we are using and relying on internally. And that's a really great library. But this library is fairly low level, and you need to write quite a bit of boilerplate code to bootstrap that and get it kind of connected to Spring Boot. So what we did is create a framework with a very Spring Boot-like programming model and API, very annotation-based, and that internally uses GraphQL Java to kind of make everything work together. And originally, we kind of envisioned this as just something that Netflix would be using, and it would be tightly integrated with our backends for tracing and logging and metrics and all these things. But after working about this on this for about a year, we realized that we had mostly just created a really great framework with a really nice developer experience just to build GraphQL services. And it wasn't really Netflix specific. So that's when we started thinking about open sourcing this, and we finally did that just a couple of months ago. So this is the framework that we are standardized on, and we have about probably 100 teams internally working with this framework and have been doing so for the last 2 years. So it's pretty battle hardened. And then you get a really nice developer experience on top of that. So let's start looking at building a DGS using the framework. So we will just be looking at IntelliJ and actually writing an app. What I've already done is I've run the Spring Initializer. So I've set up a Gradle project based on Java 11. And that's it. It's just a bare bones Spring Boot application. And then let's switch to IntelliJ. The only thing that I've added here is the dependency to the DGS framework. So this is the starter that we provide. You can see I'm on an RC release right now because I actually want to include something that we will probably release later today. So this is just the dependency that you need, the only dependency. And then the second thing I've added is our code generation plugin. What it basically does is it analyzes your schema and it generates Java types or Kotlin types for all the types defined in your schema. And that basically reduces the boilerplate you would otherwise have to write of writing Java beans that reflect your schema. Completely optional. You don't have to use code generation if you really don't want to, but it's quite convenient. So there's no code other than just a standard empty Spring Boot application here yet. So let's start writing a DGS here. So the first thing that we need is define our schema. So we create a schema.graphqls. And in the schema, we are just defining kind of the same example as what I had on the slides. So we have our query definition. A query has a shows field, which is a list of show. Show is a custom type, so we define that right here. A show should have a title. And let's say a release year of type int. And we could also, let's say, reviews, which is our list of reviews, which is another type defined here, and it has a star rating. There we go. So the first thing that I can already do based on this schema is just run my Gradle build. And because we have this code generation set up, we get some generated code, and I will just want to show what it does. So in our build directory here, I don't know why this is taking forever. In our build directory here, we now have some generated code. And the most important thing to look at is we have our show and review type here. This show type, as you can see, is just a Java bean. It has exactly the fields that we defined in our schema. But very conveniently, it also has a builder class that let us construct these types very easily. That is quite nice because especially if your types are getting bigger and you have lots of fields in it, that is just something you need. And obviously this would be extremely boring to just write out by hand every time. We can generate both to Java or Kotlin. It recognizes the language your project is using. So that works. We have a constants class, which is basically just string constants for all the types and fields in the schema. And we also have a generated client API. We'll get back to that later. So based on this code that we now have, my app is still not doing anything. What I now want to do is actually create a Java class, and we have to define what we call a data fetcher. And a data fetcher is basically the method that's responsible for returning data for one of our queries or mutations. So let's create a show data fetcher. And pretty much all the code that is DGS related, we annotate with DGS component, which is very similar to the add component you would know from Spring, but it's kind of makes it specific for the DGS framework, and the framework knows what to do with it. And now we can add a method, which we annotate with add DGS data. And a data fetcher is basically fetching data for a field on a type. So our field here is shows and our type is query. So the parent type here is query, field is shows, and now we can just have a list of show. We already have show because it was that was generated, as we have seen. And we can basically just return a list of shows. Of course, we don't have any shows yet, so let's just create a list here quickly. So typically, this is obviously something that comes from a database or some other backend service that you might have. But now we're just creating it right here, which will also demonstrate the builder that we have. So we have a new builder method here. And based on this builder, we can set our title, let's say Ozark. And I think the release year was something like 2017. Really good show, by the way. It's one of my favorites. And let's say Stranger Things. And I'm guessing that was 2016, but I actually don't have any idea. So that's it. And what we can do here is to start out with just return show data. And that's it. So I did say that we have to create a data fetcher for each field. But the framework is smart enough to know that if we return a show and the show has getters, and these getters represent the fields that we have defined in our schema, because we have some fields defined here on show, that these getters actually represent these fields, and we will basically generate at runtime the data fetchers. So you only have to just return the Java type that you have. So that should be enough to get started. So let's just run this Spring Boot application. And if we now open a browser, we can go to localhost 8080 GraphQL, and it's a query editor that we get out of the box. And what we can do here is, first of all, inspect our schema. So we get query completion, basically. So it knows, based on our schema, that we have shows, and the show has title, and the show has release year. And we can run this query, and we see that our first data fetcher is actually working. So that's pretty nice. It was pretty quick to get going. So let's make this a little bit more interesting. Let's actually go back to our schema. And what you can also do is have arguments to a query. So instead of just returning all shows, let's add a filter here, which is a title filter. and it's just going to be a string. It could also just be another object. That would be in GraphQL, we would call it an input object, but for now, let's just use a string. So one interesting thing about this is that most things by default are optional in GraphQL. If I don't specify that something isn't optional, it is by default optional. So in this case, this title filter may or may not be there. It's both fine. If I want to require this filter, I write it like this, and now it is required. But in most cases, you kind of want to prevent that. We could do the same here and the same here. These things make it required to not have null values, basically. But typically, we just keep it optional. And based on this, let's go back to our data fetcher. And what we can do here is use the input argument annotation. And the input argument is going to be of type string, and it is title filter. So it knows if we now get a query with a title filter passed in, to peel it out of the query and pass it on to this method as a string. And based on this title filter, we can null check, because as I said, it may or may not be provided. And if it is provided, we can take our show data and filter it. Let's look at the title. And if it starts with our filter, we'll include it. And otherwise, we'll just return the whole thing. So again, let's start this up. Things always start a lot faster if you're not also recording your screen. It's bad for your CPU. Anyway, this still seems to work. And now we should also be able to pass in a title filter. So let's say that we only want OZ, which should give us just Ozark. Apparently I didn't write it correctly because it's giving us everything. How did I mess that up? Well, time to start a debugger, I guess. Oh, I do know what I did wrong. I'm obviously missing the return right here. So never mind about that. Let's just test it again, and it should now hopefully work. Still doesn't. Interesting. This also kind of shows why it kind of sucks to just do this back and forward of, oh, you change a bit of code and then you go to your GraphQL UI and you try to construct a query that you might need to test this thing. And that's a very minimal process. So the next step is we finally get this to work. Yeah, there we go. The next step is definitely to look at some testing as well. So one thing that I also kind of wanted to show is that I wrote this DGS data annotation here with the parent type query and field shows. I wanted to show that to kind of give an understanding of how this works. But there's actually a nice shortcut to this, which is just DGS query. And DGS query has an optional field. And we can still provide a field name. If we don't provide it, it will just take the method name as the field name. And because it's DGS query, it knows that a parent type is query, obviously. And we also have a DGS mutation and DGS subscription. Right, so that should still give us the same result. But in the meantime, let's start looking at some testing, because as we've already seen, this kind of back and forward to the UI isn't obviously automated, and that's not ideal. So let's add a test to this application. So what we want to do here is we just want to test our query. And what we don't need to do based on the DGS framework is invoke the actual HTTP endpoint. Of course, you can do that. You could just bootstrap your application and just invoke the HTTP endpoint. But now you have to deal with JSON parsing and firing the HTTP request and setting up your port, etc. You probably need more components to start up, so the startup of your test is slower. What we can instead do is use the DGS framework, which has a query executor, and we can just use a Java API to execute queries, get a result back, and just don't bother with the HTTP layer essentially. So this query executor is used internally by the HTTP endpoint as well. So it is actually executing exactly the same code as what you would be executing if you do go through your browser. It is just a much more convenient Java API. So we are going to create this as a Spring Boot test. And what we typically want to do is provide a specific list of classes here that you want to include for this test. And that should be as minimal as possible so that we don't kind of drag in all our components and slow up start time or slow startup time. And that's all just not great. So what we need here is the DGS auto configuration that basically bootstraps the DGS framework's core. And we need our show data fetcher. And that is about it. What you can then do is use auto wiring from Spring, because now this is a Spring managed test, to get a DGS query executor. And based on this query executor, we can now execute a query. So let's define our query. And I'm just going to copy it from our browser, and we will immediately see why this kind of sucks. Because now we have to deal with how Java is doing multi-line strings, at least until recently. So if you're still not in Java 16, we are definitely not. This is just not great. So I will get back to that in a moment because we have something better. But for now, we're just passing this string. And the second argument to this is a JSON pod. And the JSON pod is used to peel out specific values of our response. We can also just look at the query response by itself and look at errors and all that. But in most cases, your test want to look at specific fields that you're getting back. So we're looking at data.shows, and we want to get all the shows and just want to get a title, and that should give us a list of string, which is titles. And now we can simply use an assert to look at the titles, and we want to make sure that it contains exactly Ozark. So that means it should only include Ozark. Then we can just use this as a unit test. If I'm not at maxed out CPU because we are streaming, this would take about 400 milliseconds, so less than half a second to start up. Takes a little bit longer now because my CPU is not doing very well. But you can see my test is successful. Well, you should always be suspicious of a passing test if it passes the first time, because usually it means that you did something wrong. So let's see if we can actually introduce a bug. And I'm just going to comment out this code. So it's not doing any filtering anymore. Run the test again, and hopefully it is going to fail this time. And there we go. And we see exactly that now we are getting 2 shows back. So we have Ozark and Stranger Things. But we were only expecting Ozark. So we caught a bug and we knew that we messed up here. So that's pretty nice. So then finally, as the very last thing to look at, I mentioned that this kind of sucks, in my opinion. It's a lot better if you use Kotlin or a more modern Java version, obviously. And what you can also do is use a generated query API. So the CodeGen plugin that we have for Gradle also generates a builder style API to create queries. And we can use that to either use that as kind of a Java client to an existing GraphQL service using a GraphQL client that's also part of the framework, or we can use it in tests to just construct our queries. So we can write a GraphQL query request. And we need two arguments to that. We need a query and a projection. So the query is the part where we ask for shows with a specific title filter. The projection is the fact that we ask for just titles. So this is going to be generated. So it's going to be shows GraphQL query, which is a builder. And based on this builder, we can see that we take a title filter. So again, we're just going to pass in a filter for Ozark. And the second argument is our projection.
Short question, can you zoom in a bit?
Oh yeah, thanks. There we go. So the second argument is our projection. That's where we want to say that we only want to get titles in this case. So we take our show projection roots. And based on that, we say, so you can see we have code completion here. So that's one nice thing. We can say if you just want to get a title. If you would also ask for like reviews, then you can see that we can get into reviews, and we also get a fields there with code completion. Let's just keep it to title here. We have our query request here, and instead of specifying this query now as a string, we're going to say query request dot serialize, and that should give us the same query but built by a Java API. This is obviously also much nicer if you have to construct queries dynamically. So if depending on input from a user, for example, you want to include or not include certain fields, if you start doing string appends, that's kind of digging a hole for yourself. Using a Java API in that case is much nicer. And we see that the test is still passing, so this has the same result as that we previously had. So that's kind of a super short overview of kind of the first steps you would take with the DGS framework and writing some tests with it as well. But you can see it's fairly easy to just get started. It feels very similar to doing Spring Web MVC, for example. If you're familiar with that, it should mostly feel familiar to write things like data fetchers. And then looking at like other things that we support, there's a long and growing list of things. So we've looked at the test framework just now. We have looked a little bit at code generation and what we can do with that. Again, that's completely optional. You don't need to use that. Instead, you could also just use existing Java types that you already have configured for, let's say, your data access layer. That's fine as well. We have really good integration with the GraphQL federation spec. So if you're in a federated architecture, that kind of just mostly just works all out of the box. We do have an example also of a federated service, basically with two DGS services behind a Apollo federated server. You have that on GitHub. There's integration with Spring Security, so we can put an add secured basically on our data fetchers. That would give you field level out Z. We have support for GraphQL subscription, so for either WebSockets or service and events. There's file uploads, all sorts of mechanisms for error handling. I mentioned there's a GraphQL client, so your Java service can also be a client to another GraphQL server, which could either be a DGS or some implementation in JavaScript or whatever. There's lots of instrumentation you can plug in. Instrumentation is things like maybe distributed logging or tracing. These are things we've all built internally based on our infrastructure, but you can very easily plug your own mechanisms in as well. And one example of instrumentation is we've recently added micrometer metrics to OSS as well. So you get metrics basically for free if you have a backend for Micrometer. So with that, we're kind of running out of time. So definitely take a look at the documentation page. That kind of gets you up get going with building the framework. We have a bunch of example applications as well, which are mentioned there that you can look at both in Kotlin and in Java. So yeah, maybe ask some questions and let's keep it with that.
Thank you, Paul, for the great presentation, and of course to Netflix for open sourcing the framework. We do have some questions, so I'll just quickly go through them. And one of them was, can you show us how to solve the n+1 problem with DGS? And I'm not sure if this rings a bell to you.
Yes, absolutely. So I'm not going to show it because it will involve a little bit more time, but I will show you the documentation. It's actually not hard at all, but it will take more than like a minute. So this is the documentation that we have. This is a getting started guide. One of the pages here is async data fetching, and that's exactly about the n+1 problem. So this is basically if, as in my example, my show had reviews, how are you going to load multiple reviews if you're asking for multiple shows as well? That would out of the box give you the n+1 problem, and if you would go to like a SQL database, it would be very inefficient. And there's batch loading included in a framework that kind of solves that for you.
Okay, cool. The next question is about somebody asking for details about caching being difficult with REST.
Yeah, I made a very generic statement about that. And my experience is that in practice, so kind of not looking at it theoretical, but in practice, REST services are generally not as cacheable as you might think. And that is a very broad statement. And I know that it is not always true, definitely not. If you actually spend time designing your service to be cacheable, REST definitely has an advantage. But then there's also mechanisms in GraphQL that you can leverage, such as query caching, to kind of get to the same points. There was a really interesting presentation from the New York Times, who are also big GraphQL users, who talked specifically about caching.
Okay, thanks. And the next one is about, I think in your schema, you chose not to use mandatory fields for example, a title. Is there a specific reason for that?
It is technically you can do either way, and in the specification doesn't say anything about it. What we have found just by experimenting with it is that schemas that are mostly nullable, so mostly optional, are easier to use from a UI perspective. But it really depends on the specific scenario, and there's definitely also cases where you do want to use things required. But generally, 90% of the fields in our schemas are all optional. But again, this is something that we do at Netflix. I'm not sure everyone else in the GraphQL community is doing the same thing, but it is what I've been seeing mostly.
Okay, so we have more questions coming in, but we have time, so that's good. The GraphQL Java Kickstart project has been around for several years. Why did you feel the need to create your own framework?
We actually started with a Kickstart framework. So in the very early days, when we started with GraphQL, that was actually what we were based on. But the most important reason why we stepped away from it, also pretty early on, is that at least back in those days, it wasn't extensible in a way that worked really well for us. We, for example, needed to get our security plugged in as well, and distributed tracing and logging and all these things. And the existing framework is getting more in our way than it was actually providing for us. So we decided to basically take the pain, do something ourselves, and just build it more specific to what we needed. Remember, back in those days, we were also not anticipating that we would open source this. We were just solving our problems, and for us, it was easier to just do that based on our own stack. So that's kind of how it happened. I think now we probably have a nicer and more complete API than alternatives, but obviously I'm very biased.
That could very well be indeed. The next one, when returning shows from a real database, we are fetching complete objects, including all children objects. Would you recommend a certain database type with GraphQL for performance/convenience?
At Netflix, we have really a wide variety of data stores that we're using. A lot of teams in the GraphQL space are actually just using relational databases, so Postgres-like databases. We have quite a bit of Cassandra as well. Cassandra is probably I mean, it's great for some things. It's probably the worst if you just want something convenient. So unless you have massive scale, I wouldn't recommend it. I think something like a document store such as Mongo would actually be a really nice fit, but for no specific reason at all, not a lot of teams at Netflix are using that. It's mostly just what folks are familiar with and what we have available, but it would be a nice fit for something like GraphQL. But then we also have a lot of GraphQL services that sit on top of a gRPC backend, for example, because we have a lot of gRPC services already available. So your data can also just come from different places. It doesn't necessarily have to come from a database.
Exactly. Next, is there a nice way to implement custom validators for the fields in GraphQL?
No. We have an open issue about this, and we are not quite sure what the best way is to go about this. We have experimented a little bit with using like Hibernate Validator, for example. We kind of don't want to pull in more dependencies, so that's kind of holding it back. So yeah, long story short, undecided, but we're thinking about it. If you have feedback about it or ideas about it, definitely just let us know on GitHub.
Yes, and the next one, I think you already mentioned something about batching, but are batched queries supported?
Batch queries are supported, yes. That's the page that's still on the screen.
Exactly. Okay. Then why do you
actually,
make sure?
I just realized probably that person was asking something else. This is batch loading, and batch queries is something slightly different. Batch queries are actually not supported currently. That is if you have multiple independent queries in the same request. We have never had a need for it at Netflix, but this also recently came up in OSS, and we will add support for it because it makes sense.
Yeah, no, that's nice. Who do you make sure your graph and data how do you make sure your graph and data fetches are in sync? E.g. with nullable fields or input arguments. Is there support for safe listing? There
is not. We have been thinking about this. So first of all, this generally doesn't seem to be a big problem. We don't often run into issues with this. You might forget something or miswrite something kind of during development while you're writing the method, but it is such an obvious mistake that you wouldn't be searching for it very long. So as soon as you either test it manually or test it with a unit test, you will find out. However, I have been kind of considering maybe write a IntelliJ plugin or something like that to kind of get better across the board validation between your data fetchers and schema, but haven't gotten to it yet. Oh, that sounds like a nice plugin. I think there are also already existing plugins where you can maybe hook into, but yeah, that's definitely something we're looking at.
do you think that you can leverage this framework to use as proxy for GraphQL, but the resolvers would call REST API services instead of re-implementing the business logic in GraphQL itself?
This is actually something that has been coming up many times at Netflix as well. In most cases, that is actually about, we already have a gRPC service. Can't we just somehow generate a GraphQL endpoint? That is probably even more relevant for gRPC, because with gRPC, you also have a schema. The schema is in protobuf. If you look at it purely technically, that would be possible. And we have some integration for this in the framework that some internal teams are using. There's a mechanism in the framework, which is also in documentation, where you can basically define your schema and your data fetchers programmatically. So that can be completely dynamic. So you can use that to transform one sort of schema to a GraphQL schema. So that works perfectly. However, what we have found is that it is almost never a good idea. The reason is that a GraphQL API is fundamentally different than either REST or gRPC. And if you want to have a well-designed GraphQL API, you basically want to be building that in most cases just from scratch. And it is worth the effort to write some extra code for that. Of course, that doesn't mean you have to rewrite everything. You can just add the DGS framework to an existing REST application, if that's also Spring Boot, and just use the same code to get data from the database and validation and all these things, and basically just expose your data to GraphQL. That's a very thin layer. But this automatic conversion just doesn't really work well if the schema design is important.
Okay, next one. How do you apply authorizations to parts of your graph?
Right. So what we have, if you would go to this data fetcher one more time, where's my data fetcher? There it is. We have support for add secured. I don't have add secured in this application because I don't have the dependency. But you can basically just do this, and that will give you, so let's say we pass in some sort of group. That will give you outz on this specific field. So this would be on the shows field. Now let's say that I want to give everyone access to the title of a show, but we don't want to give everyone access to let's say the reviews. We just write an extra data fetcher specifically for the reviews in that case, and we just annotate that method with add secured. So based on add secured, you can do field level outz.
Okay. And the next one, if you have a big monolith app and you need to expose as GraphQL API, would you convert the Swagger schema to GraphQL schema and implement the resolvers using DGS framework that calls the REST services?
I think the only valid answer here is it depends. But kind of going back to the previous answer about can we automatically convert from one schema or one type of integration, like, so let's say a REST API to GraphQL. Again, yeah, you can, probably shouldn't. Should you do it in the same application or do remote calls? That really depends on the state of the existing application, I would say. If that's something you're actively developing and you're happy with the code base and you don't have any problems with dependencies and startup time and things like that, I would definitely just add the DGS framework to that existing application. We have done that many times at Netflix as well. If, however, the existing application is kind of a pain in the ass to work with for whatever reason, maybe it's just technical debt, maybe it's just some really bad dependencies that you need to have there, it might be nicer to just start from scratch so that you have a better developer turnaround basically, and just call out to your existing REST service. And again, we've also done that at Netflix. It really depends on your starting point.
Yeah, oh, nice. Are you also considering to open source the federation server you developed as well?
Considering, yes, but we don't have any concrete plans. So just to give a little bit of background, I mentioned that the federation specification is something that Apollo came out with, and we are collaborating on the specification with them. They have a really good tool set around federation and managing a schema and getting insights on how your schema is being used. And these things are super important. Because the infrastructure that we already had at Netflix for distributed tracing and metrics, we basically wanted to base all these things on that existing infrastructure because it's part of a much bigger picture, obviously. So we decided to implement our own implementation of the federation spec that is done in Kotlin. It is not super Netflix specific, but there are some Netflix specifics in there. The team that's responsible for that, I'm not part of that team, but I'm working very closely with them. They often go, oh, maybe we should also consider open sourcing, but it is obviously a huge time commitment, and they haven't figured out if it's for the effort, etc. If that ever happens, that would be interesting. If it doesn't, again, Apollo has a pretty good stack that is actually very similar to the Netflix stack, just with all the existing infrastructure that we have.
Okay, yeah, there were a lot of questions. Thank you for all those questions. That was very useful also for the answers, by the way. I think this is it. Thank you, Paul.
Yeah, thanks for having me.
And to all our viewers at home, thank you for watching. I hope we can soon meet again in real person, but until then, don't forget to subscribe and click the bell icon to make sure that you at least don't miss the next session. Thanks.